Hello, in this short video I will solve the following A-level problem. Determine equations of the tangent lines that one can draw from the point A with coordinates -2 and -3 to the curve y equals to 4x minus x squared. Pause the video at this point and give it a try. So the first thing that we have to know is that this point is not on the curve, and it is easy to check. For example, if you replace x with -2, so it becomes -8 minus 4 is -12, and it is not equal to -3. So this means that this point is outside, somewhere outside this curve. Of course, this curve is a parabola, but I don't want to be precise to waste time because that doesn't matter. So what matters is that this is a curve, okay, and this is a point which is not on the curve, and I want to draw a tangent line from that point to the curve. Of course, might be because of the curvature here, I can draw more than one tangent line, and according to the problem, probably we know there are more than one tangent lines there, but that is not important. So in a scratch paper, you just sketch some graph for yourself, and then, for example, this is the point A with those coordinates -2 and -3, and let us pretend that this is our curve 4x minus x squared. Okay, so in order to find the equation of a tangent line, I need to know something about the points of tangency, yes? Because if I want to find the slope of this line, I have to differentiate the function and put the x-coordinate of the point of tangency inside the derivative, and that number that I get in this way will be the k-value of the tangent line, the slope of the tangent line. So we can pretend that this t is given to us, okay? This is one trick that you have in mind. You should have in mind when you want to solve these kinds of problems in which the point is not on the curve and you are supposed to draw a tangent line there. So I take this point t and I give it alpha and beta, the names alpha and beta, assume that this is my point of tangency. So then the rest of it should be clear. I find the k value by differentiating this function. So y prime is just 4 minus 2x, and the k value of the tangent line is when I replace x with the x coordinate of the point of tangency, okay? Of course, I agree with you that I couldn't find the answer to k yet, but don't worry, I will tell you how to do it. So we pretend that everything is given to us. Then I would write my equation, y minus y naught equals to the k times x minus x naught, in which k is this. So 4 minus 2 alpha, x minus x naught. X naught and y naught could be any point of this line. So let us choose this point first. So this becomes alpha, and y minus y naught. Y naught is beta. But because alpha and beta are on this curve, so it means the coordinates of this point will satisfy this equation. It means that if I replace y with beta and replace x with alpha, then this relation holds. So instead of beta here, I put that expression. Okay, so if I ask you what this is the supposedly equation for this tangent line. Okay, but the problem is that I cannot claim I found the equation because alpha is still not known. But I have one piece of information that I haven't used so far, and that is the fact that this line is supposed to pass through this point as well. So this means the coordinates of this point will also satisfy this equation, meaning that if I replace y with y value, replace x with x value, this equation should hold. Okay, so I will do that. Instead of y, I put -3. I multiply the minus sign in, so it becomes -4 alpha plus alpha squared. Here, for the time being, I copy and paste this, but for x, I put the x coordinate, which is -2, and then minus alpha. And then you see that this is just an equation in one unknown. I will solve it and find alpha. Put alpha back here, then I have my equation. Okay, so let us see how it works. So here, I just write this, and I start multiplying. So 4 times -2 -8, 4 times minus alpha, and then this is +4 alpha, and then finally +2 alpha squared. This one and that one are simplified. I move alpha squared to the right hand side. 2 alpha squared minus alpha squared is simply alpha squared. and then I have minus 4 alpha, move it here, it becomes 4 alpha, then I have minus 3, and then minus 8 here, so if I move it here, it becomes minus 5 equals to 0. We can use PQ formula or BC formula, or here, it is much simpler to factorize, so I put 1 alpha here and 1 alpha there. I need two numbers whose sum is positive 4, and the product is minus 5. So it is plus 1 and minus 1. Okay? So this means that there are two answers for alpha. Either alpha is 1 or alpha is minus 5. Okay, so if alpha is 1, I put it back in this equation, and then I will find my equation of the tangent line. So if alpha is 1, I put it up there. So where's my stick here? So instead of alpha, I put 1, 4 minus 1, 3, so it becomes y minus 3 equals to, instead of alpha, I put 1, so 4 minus 2, it's 2, and then x minus 1. And of course, I simplify this a little bit because we usually prefer to have y alone on the left side. So it becomes 2x minus 2. I move minus 3 to the other side, so it becomes plus 1. So this is one equation, but we also have another alternative, which is minus 5. So I replace alpha with minus 5. So it is minus 20. This becomes minus 25, so minus 45. And then it becomes plus 45. So it becomes y plus 45 equals to. Instead of alpha, I put minus 5. So it becomes 10, 14. And then x minus minus 5, which is plus 5. And then as usual, I simplify it again. So this becomes y equals to 14x. 14 times 5 is 70. 70 minus 45 is 25. So these are two tangents that I can draw from that point outside the curve to the curve. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.